Hi all, welcome to my fourth lecture in probability. We have certain special probability distributions to study as part of our PG program. Of that, in this lecture, I will be starting with binomial distribution. Before we see what a binomial distribution is, we need to understand what are Bernoulli trials. Many experiments or trials are dichotomous in nature. When I say dichotomous, there are just two possibilities. Let us consider tossing a coin. There are two outcomes possible for that experiment, head or tail. If we consider any one of these outcomes as a success, say, let the occurrence of head be treated as success, then occurrence of tail will be treated as failure. It's like saying there are just two possibilities, either a yes or a no. Like we say in the case of binary, there is just a 0 and there is just a 1. There is no consideration for any possibilities in between. So, such experiments are called dichotomous in nature. There is either a success or a failure. Okay. So, in the case of a coin toss, if we consider any one of these outcomes, there is no particular interest in the head alone. You can consider any one of the outcome as a success, then the other outcome can be treated as a failure. The outcome of any one trial is independent of the outcome of another trial. Suppose I toss a coin, I obtain a head. I toss a coin again. The occurrence of head in the previous trial will in no way affect the outcome in the next trial. Such independent trials, which have only two outcomes, and these outcomes can be generally be referred to as a success or a failure. Such trials are called Bernoulli trials. Okay, suppose there are n independent such events of a kind. Suppose we are performing, say you consider the case of a coin toss itself, you are performing n coin tosses. Okay, and in each trial, you are monitoring some particular thing, say occurrence of head as success and the occurrence of tail as failure. So when you toss a coin, you are not very sure what the outcome is going to be. So in each trial, there will be a probability of success P and there will be a probability of failure which can be given by 1 minus P. Okay, I hope this is understandable. Now, suppose we are trying to select m events out of n. What are the different ways to select to make such a selection? We had learned in the previous lecture something called combinations. So you can make these many number of selection of m events from the given n events. Okay, so NCM is the number of ways to select m out of n. Now, I would like to know what is the probability that exactly m events will only succeed out of n. Okay, when I say only exactly m events will succeed, it means I should also obtain that the rest n minus m events should fail, isn't it? n events തന്നിട്ടുണ്ട്, അതിൽ m events ഞാൻ സെലക്ട് ചെയ്തെടുക്കുകയാണ്. എന്നിട്ട് ഞാൻ പറയുകയാണ് ഞാൻ സെലക്ട് ചെയ്ത് m ഈവൻസ് മാത്രമേ സക്സീഡ് ചെയ്യാൻ പാടുള്ളൂ. അതിൻ്റെ സാധ്യത എന്താണ് എന്ന് ചോദിക്കുമ്പോൾ m ഈവൻസ് സക്സീഡ് ചെയ്യുക എന്ന് പറയുമ്പോൾ I should also ensure that the rest n minus m should fail. Then only I can say exactly only these many number of events are succeeding out of n. So I need to have two things happening together. m events succeed ചെയ്യുക, അതിനൊപ്പം തന്നെ ബാക്കിയുള്ള n മൈനസ് m നിർബന്ധമായിട്ടും ഫെയിൽ ആവണം. എന്നാലേ I will get the probability that exactly m events will succeed out of n. Now, we had seen in the previous lectures, I want if something can happen in this many different ways, another thing can happen in this many different ways, then the probability of both happening together, we multiplied the individual probabilities. In some cases, when the events were independent, we simply multiplied the probabilities. When they were dependent, we used conditional probability. Here we had already mentioned they are independent events. So you can simply multiply the probabilities. So the probability that exactly m events will succeed out of n is given by NCM. These are the number of ways in which I can select m out of n, and each has a probability of p. So for m events, the probability of success would be p raised to m, and every event has a probability of failure q, which is 1 minus p, and I want to ensure that the rest n minus m events fail. So the probability of failure for the rest n minus m events is given by q raised to n minus m, which will give me, this entire thing will give me the probability that exactly m events will succeed out of n. Okay, അത് മനസ്സിലായി എന്ന് വിചാരിക്കുന്നു. If you have gone closely through the previous lectures, I don't think there is a problem in understanding this thing. Now, instead of NCM, you may replace it with n factorial divided by n minus m factorial times m factorial. Rest remaining the same. This function is called the probability distribution function. And this is the probability distribution function which is called binomial distribution function for x, where what is the random variable x that we are looking at? We are looking at the successes in n trials. Okay. അപ്പോൾ n ട്രയൽസിൽ എത്ര സക്സസ്സുകളുണ്ട് എന്ന് മോണിറ്റർ ചെയ്യുന്ന അതാണ് നമ്മുടെ റാൻഡം വേരിയബിൾ. ഇവിടെ എക്സ് എന്ന് പറയുന്ന റാൻഡം വേരിയബിൾ ഇസ് ദി സക്സസ്സസ് ഇൻ n trials, and this is the probability distribution function which we call binomial distribution function. Now, the next curiosity is, why is this thing called binomial distribution? Now, if you look at here, if we put different values of m, say, what are the different values possible for m? You are selecting these many events out of the given number of events n, അല്ലേ? അപ്പോൾ എമ്മിന് മാക്സിമം എടുക്കാൻ പറ്റുന്ന വാല്യൂ എന്ന് പറയുന്നത് n ആണ്. എം എന്ന് പറയുന്നത് ഒരു ഇവൻറ്റും സക്സീഡ് ചെയ്യാതിരിക്കുക എന്നുള്ളതുമാകാം. സോ യു ക്യാൻ ഹാവ് എം 0 ഓൾസോ. ഒരു ഇവൻറ്റും സെലക്ട് ചെയ്യാതിരിക്കാം, അല്ലെങ്കിൽ എല്ലാ ഈവൻസും സെലക്ട് ചെയ്യാം. സോ എം ക്യാൻ റേഞ്ച് ബിറ്റ്വീൻ 0 to n. Now if you plug in different values of m in this relation, you will be getting it like this. അപ്പോൾ നമ്മൾ നോക്കുന്ന റാൻഡം വേരിയബിൾ എന്ന് പറയുന്നത് നമ്മുടെ സക്സസ് എത്ര എണ്ണം ഉണ്ട് എന്നുള്ളതാണല്ലോ. അപ്പോൾ സപ്പോസ് യുവർ എക്സ് ഇസ് 0. എക്സ് എന്ന് പറയുന്നത് എം തന്നെയാണ്. എം നമ്പർ ഓഫ് ഈവൻറ്റ്സ് എടുക്കുന്നു, ആ എമ്മും സക്സീഡ് ചെയ്യുന്നു എന്നുള്ളതാണല്ലോ നമ്മൾ നേരത്തെ പറഞ്ഞിരുന്നത്. സോ യു ക്യാൻ റൈറ്റ് ലൈക്ക് ദിസ്: എഫ് ഓഫ് എക്സ് ഈക്വൽ ടു എം ഈക്വൽ ടു, ലെറ്റ് ഇറ്റ് ബി 0. When you plug in the value m equal to 0, this is what you get: q raised to n. Now when you plug in the value m equal to 1, you get n by 1 factorial p q raised to n minus 1. Similarly, when x equal to m equal to 2, you get such a term, etc. Now if you closely examine all these terms, you will understand that these terms are nothing but the terms which appear in the binomial expansion of q plus p raised to n. Binomial expansion of q plus p raised to n is given like this: q raised to n plus np q raised to n minus 1. n by 1 factorial ഉണ്ട്, n എന്ന് മാത്രമേ എഴുതിയിട്ടുള്ളൂ. Plus next term is n into n minus 1 by 2 factorial p square q raised to n minus 2, etc. etc. അങ്ങനെ ക്യൂവിൻ്റെ പവർ 1 വീതം കുറയും, പിയുടെ പവർ 1 വീതം കൂടി വരും. ലാസ്റ്റ് q raised to n minus n എന്ന് വരുന്നൊരു ടേം ഉണ്ടാവും. ആൻഡ് ദാറ്റ് വിൽ ഗിവ് യു ദി ലാസ്റ്റ് ടേം വിച്ച് ഇസ് p raised to n. ബൈനോമിയൽ എക്സ്പാൻഷനിലെ എല്ലാ ടേംസും നമുക്കിവിടെ എമ്മിന് പല വാല്യൂസ് ഇട്ട് കൊടുക്കുമ്പോൾ ഈ ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷനിൽ നിന്ന് ജനറേറ്റ് ചെയ്യാൻ പറ്റുന്നത് കൊണ്ട് ദിസ് ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷൻ ഇസ് കോൾഡ് ബൈനോമിയൽ ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷൻ. ഓക്കെ, അത് വെച്ചിട്ടൊരു പ്രോബ്ലം ഇവിടെ ചെയ്തിട്ടുണ്ട്. വാട്ട് ഈസ് ദ പ്രോബബിലിറ്റി ദാറ്റ് 1 വിൽ അപ്പിയർ എക്സാക്ട്ലി 4 ടൈംസ് if a die is thrown 10 times? ചോദ്യം ഒന്നും കൂടി പറയാം. What is the probability that a 1 will appear exactly 4 times if a die is thrown 10 times? അപ്പോൾ എൻ്റെ ടോട്ടൽ നമ്പർ ഓഫ് ട്രയൽസ് n എന്ന് പറയുന്നത് 10 ആണ്. ഇനി ഞാനിവിടെ നോക്കുന്ന ഒരു ഡൈയിൽ പോസിബിൾ ആയിട്ടുള്ള 6 ഔട്ട്കംസ് ഉണ്ട്. ഞാൻ സക്സസ് ആയിട്ട് കരുതുന്നത് ഒരു 1 അപ്പിയർ ചെയ്യുക, അങ്ങനെ ഒരു ഔട്ട്കം വരുന്നതിനെയാണ് ഞാൻ സക്സസ് ആയിട്ട് ട്രീറ്റ് ചെയ്യുന്നത്. എന്നോട് ചോദിച്ചിരിക്കുന്നത് 4 തവണ 1 കിട്ടുന്ന അതിൻ്റെ പ്രോബബിലിറ്റി എത്രയാണ് എന്നുള്ളത് കണ്ടുപിടിക്കാനാണ്. സോ മൈ എം ഇസ് ഈക്വൽ ടു 4. അപ്പോൾ റെസ്റ്റ് n മൈനസ് എം എന്ന് പറയുന്നത് എത്രയാണ്? 6 ആണ്. Probability of success. What is the probability of getting a 1 in a die? It is 1 by 6. അല്ലേ? Then what is the probability of failure? Failure means there are 5 outcomes other than 1 possible in a die. So the probability of failure would be 5 by 6. Probability of success is 1 by 6. And now I want to check exactly 4 times I get 4 സക്സസ് കിട്ടാനുള്ള സാധ്യത എന്താണ് എന്നാണ് ചോദ്യം. സോ ഐ വിൽ ജസ്റ്റ് പ്ലഗ് ഇൻ ഓൾ ദീസ് വാല്യൂസ് ഇൻ ദി ഫോർമുല ആൻഡ് ഐ ഗെറ്റ് ഇറ്റ് ആസ് 0.0543. ഓക്കെ, ഇനി ഏതൊരു പ്രോബബിലിറ്റി ഡിസ്ട്രിബ്യൂഷനും സാറ്റിസ്ഫൈ ചെയ്യേണ്ട ഒരു റിക്വയർമെൻറ്റും ഇതിന് മുമ്പത്തെ ലെക്ചറിലും പറഞ്ഞിട്ടുണ്ടായിരുന്നു. സം ഓഫ് ഓൾ ഇൻഡിവിജ്വൽ പ്രോബബിലിറ്റീസ് ഷുഡ് ഗിവ് യു 1. So here it just means summation m equal to 0 to n f of m should be equal to 1. Now instead of f of m, I am just plugging in this relation. Okay, NCM p raised to m q raised to n minus m equal to 1. Now we know in the case of binomial distribution, this thing summation, this thing NCM p raised to m q raised to n minus m is nothing but q plus p raised to n. അല്ലേ? ഇനി q എന്താണ്? q is the probability of failure which is given by 1 minus p. So your q plus p would be just 1. So summation this quantity is equal to q plus p raised to n will become 1 raised to n, which is nothing but 1. So let this be your first equation. Instead of q, you can as well write 1 minus p. Keto. Now, the general procedure that we will be following with all distributions is we are going to evaluate the average number of successes. We will be finding out the variance and we will be finding out the standard deviation. This we will do for all the distributions that we are going to study. In the case of binomial distribution, let us evaluate the mean or average number of successes, which is given by m bar. Okay. Now, if you remember our previous lecture, we had seen that the method of evaluating expectation value or mean is to take like this summation I xi pi, where the weighting is done with probabilities, individual probabilities. So this is how you found out the expectation value. If you remember our previous lecture, I had mentioned this is how we find out the average value or the expectation value. So here instead of xi we have m, and instead of pi we have f of m. So my m bar would be a summation for different values of m. Now m can range from 0 to n. So summation m goes from 0 to n. mfm would be my m bar. Now in order to evaluate m bar, I am doing certain mathematical uh, gimmicks. So for that, let me consider this equation 1 and I'm just writing it again. Equation 1 was summation m goes from 0 to n ncm p raised to m q raised to n minus m. അതിൽ qന് പകരം just put in 1 minus p. Okay, so my equation 1 becomes like this. Now differentiating equation 1 with respect to p, you see that I have p as a function of p and I also have 1 minus p here. So I differentiate it using product rule. I take one as a constant, differentiate the other, then the other way around. Okay, so let's take this one as a constant and differentiating the first term, I get m times p raised to m minus 1. NCM remains the same. Then 1 minus p raised to n minus m. So that's one term plus summation NCM. Now you keep p raised to m as a constant and differentiate the second term. Now this would be my derivative, and when I differentiate my 1, I get a 0 on the RHS. Now just you consider NCM is common for both these terms. Taking NCM common, then I have m p raised to m minus 1, 1 minus p raised to n minus m. And here I have a minus sign, so that's this minus. Then the rest of the terms written in order, which gives me something, all these give me equal to 0. Now I'm taking this term, negative term, to the RHS. This is what I'd be getting. Okay. Now in my RHS I have a term involving m. Here again I have a term involving m. There are a lot of terms in common. NCM is also common. NCM is common. Since this term is with a negative sign, I take this term to the LHS, and that's what I have here. Now I multiply throughout by p into 1 minus p. Okay, So my first term becomes p raised to m. My second term, I am writing it like this itself. 1 minus p raised to n minus m, I write it like that. Then the 1 minus p that I've multiplied with, I'm writing it separately. Then here in the second term, again this operation p into 1 minus p, that p I'm writing it separately. P raised to m I retain as such. Then 1 minus p raised to n minus m minus 1 will become 1 minus p raised to n minus m. Now on my right hand side, again p into 1 minus p, I write it as np. I can take that p outside the summation because summation is for m equal to 0 to n. And rest of the terms become like this. Okay. Now I have several terms in common. P raised to m into 1 minus p raised to n minus m is common. Then what do I have remaining? M times 1 minus p plus m times p, isn't it? So that's what I have on my LHS, and on my RHS I am writing like this. So if you look at both the terms in the LHS and RHS, in the RHS I have this term NP times summation NCM p raised to m 1 minus p raised to n minus m. Now what is this summation? This summation is nothing but q plus p raised to n. But in the case of binomial distribution, we just saw in the previous slide that it is equal to 1. Okay. So on my RHS, I just have NP. And now here the terms within the bracket, I will have M minus MP plus MP, and that minus MP and plus MP cancel with each other. So I just have a term M within the bracket. So on my LHS, I will have M times NCM p raised to m 1 minus p raised to n minus m. Now, what is this thing? This is nothing but summation m times fm. This is the binomial distribution function, isn't it? So, I write it as m times fm, and on my RHS I have np. Now, what is this summation mfm? Summation mfm is nothing but my m bar, or the average number of successes. Okay, so in the case of binomial distribution, average number of successes m bar is nothing but np. Okay, how to evaluate the variance and standard deviation, that I'll deal with in the next lecture, which will be part 2 of binomial distribution function. Thank you.